Okay, before we hit let's go, I do want to say, just so everyone knows what to expect, there's going to be three components to this. So it's not just going to be like one problem we're working with. It's going to be three components. It's going to start with, I think they call it a bug fixing, where basically the algorithm's already written, but you have to find the one flaw in it. There's like one line that's going to be wrong. Then the second one is going to be, I'm pretty sure it's called a recovery, and it's where you're trying to come up with one or more lines that that fit into kind of like a blank space, you know, like you got to fill in the blank kind of thing. And some of them, like a lot of them, are really short. One of them is just like part of a line or something like that. Some of them are like quite a few lines, so like it really it does depend. And then the third one is the code writing, where they basically just give you the description of the task, and then it's up to you to write the whole algorithm. And that's those are the ones I like. I mean, the first two I find a little stressful, but hopefully it shouldn't be too bad. Anyway, it's a timed challenge, so I'm gonna have to try to move fast here. But you know, whether or not we win it, main thing is that we have fun and that we learn something. So let's go. Okay, the existence of a triangle with the given sides. And what we're trying to say is, yeah, okay. So given three sides, we want to see, could a triangle be formed? We've got this thing that says compare numbers, sides.reverse. I think what we're trying to do is sides.sort. So let's try running that and see if that passed the test. Yep, there we go. Reverse, that's a new one. I haven't seen that one before. So remember, sort is something that takes in a sorting function. So this is our sorting function here. The reason it's returning a minus b and not like, some sort of like, if a is less than b, do this, or that sort of thing. Basically, the way sorting functions work is, as it's going through the array and comparing pairs of numbers, the way it decides whether or not to switch those numbers is whether it's getting a positive or negative value back from the sorting function. The reason we want a sorting function is in here, the reason we want the sorting function is because without it, by default, like if we don't put anything in here, then it's going to use a lexicographic sort. So kind of like the order of the words in a dictionary, you know? And that's not ideal for numbers, because with numbers, sometimes that means we're going to get stuff like this, where it's like, we'll get like 1, 2, 21, 3, something like that. So it's not exactly sorting them the way we want to, unless we give it this specific sorting function. So this sorting function is not too complicated. They could be more complicated than this depending on how we're trying to sort them. Maybe we're trying to sort by like number of factors or something like that. Like there can be other ways. We can even be sorting according to more than one thing. So for example, maybe it's number of factors, but then on top of that, in the case that the factors are equal, the sort of tiebreaker will be the size of the number, or something like that, So we can have multiple conflicting interests here. Okay, now in terms of, I didn't actually go through the description. It's a bit stressful because the description shows up as soon as this shows up. So like you're on the clock as soon as you see the description. I believe I'm not on the clock right now, by the way, so in case anyone was worrying. What was I going to say? Yeah, so the description here, we're trying to see, like, given these three sides, could you form a triangle with that? And the reason that we would say that the first example is false is because if your side lengths are 1, 2, and 10, well, okay, here's the 10, right? And then we need to sort of like bridge the gap here, like the 1 here and the 2 here need to like somehow meet each other, but there's no way they possibly could. I mean, even if we lie them totally flat here, like along the other side, there's like 7 units in between them, so definitely not going to happen. As opposed to something like this, where 6 and 5 are pretty close to each other, so maybe that's 6, maybe that's 5, and then the 2 fits in there. Boom, it works. So the main thing is we don't want a situation where the longest side is greater than the sum of the other two sides. That's the situation we're trying to avoid. So if we do find that these first two sides are greater than the last one, then we're good. You know, we return true. Otherwise, we return false. The thing is, in this case, you know, the 6 was the longest one, so we can't just go in order, and that's why we do the sort at the beginning here. So first we sort the numbers, so basically something like this. It starts out as 6, 2, 5, but after we sort it, we're gonna get 2, 5, 6, and then basically it just says, well, 2 plus 5 is 7, that's greater than 6, so we're good. Return true. Okay, great. So that's the first one. Yeah, that was a bug fix. Let's do the recovery. Yeah. Okay, what are we trying to produce here? Oh boy. Okay, so this is a hash map one, right? So for this problem, yeah, okay, this is like the file name problem. So we're given a bunch of file names, and just like on a computer, we want to store the file names, well, the way like like Windows or OS 10 or something like that, as far as I know, would store them, right? So if we already have something called doc, then the next one is going to be doc1, and then image is fine, but then we want to save something called doc1, but there's already a doc1, so we want to call that doc1. Okay, so this is a really like kind of overkill, very I would call excessive implementation. Like this algorithm it's a lot for this particular problem, especially considering, like, you know, the constraints are tiny. Anyway, the point is, what we're trying to do, where even was it? Let me reset. I'm getting lost in this. Okay, so basically, yeah, we want to fill in this part here. So let's take a look at what it's doing. Nice use of comments. We don't often see a lot of those in these. Okay, so first of all, the calculate hash function. This is basically deciding where to store it in the hash map. Now, the thing is, like, we're talking about a hash map. That's a data structure. We could look at like the visualgo for that. There's a good one. But for now, you know, since we're on the clock, let's just try to understand this. So with a hash map, we have 2 primes, pretty large primes. I think these are prime anyway. I could be wrong. Anyway, I'm pretty sure that's the idea, that you have these 2 fairly large prime numbers. And we start with a hash value 0. We're going through a loop here, and it's just going through the string, right, through the length of the string. And it's basically saying that the hash value, at each turn, you're going to multiply the hash value by whatever it was, starting at 0, multiply it by p, and then add on to that the character code of each string. So we're doing character code at I. And then we're doing that mod m, which is the larger of the 2 primes. And we want to make this a prime so that so we get unique values as we're sort of cycling through, or at least I think the minimum requirement is that it has to be relatively prime to the other number, but I could be wrong about that. Anyway, basically what it's doing is it's taking the string and it's representing it as sort of a unique number. That's the idea. Okay, so then that's just declaring this function up here, but let's get into the actual problem. I'm surprised they're using const, but then var and not let. That's a little strange. Anyway, const hash map size is names.length multiplied by 2. Okay, that's how big we're going to make the hash map. Basically the size of this array multiplied by 2. Maybe we'll find out why that is, but hash map we're going to say is this empty array to begin with. Result is going to be an empty array, and result I'm assuming is what we're going to be returning at the end, so it's going to be like this thing. Let's just check on that. Yeah, return result. Okay, great. So here we've got a function for searching the hash map, and it takes 2 arguments, position and hash. So basically it starts with this position, and we're trying to say, like, as far as I understand, this is kind of like where we want to put it in the hash map, and then it's going to put it there like if it can, and otherwise it's going to sort of move on to the next one. So let's take a look. So yeah, hash map at position at 0. So while, so there's a loop, right? While hash map at position at 0 is not an empty string, and hash map at position at 1 is not hash. Okay, so basically the hash map is gonna, well, we'll see this downstairs here. We're going to go through this map, I guess, after we've determined this function, after we've declared it. We'll go through this loop, and it's going to go from I to hash map size, so basically double the length of the original array. And then for the hash map, it's going to push empty string. Well, okay, for each entry of the hash map, we're going to have an array of length 3, and it's going to be an empty string, and then it starts out as a -1 and then a 0 at the end. And okay, so this first one is basically the string itself, like what's being stored in the hash map. This one over here, I think is going to be like the hash, like the actual code that we're getting from calculate hash up here. And then the third one is, I think, like this number. Again, I think it's, all right, sorry, it's that one actually. The other one came from the original, but yeah, I'm pretty sure that's what the third thing is going to represent. Okay, so yeah, we didn't complete this one yet. Basically, the idea is that while we're starting at position, right, and we're saying that thing at position, if that first thing is not empty, yeah, if it's something else, and if this thing right here is not that, like the hash we've been given as the argument for the function, then move on. Move on to the next position and loop around if you have to. That's why we've got mod hash map size, so it's kind of like circular, it's cyclic, it's repeating. Okay, so then basically it's saying, okay, by default, you want to move on if this isn't empty, right? If you get to the thing in the hash map and this first thing is not empty, you probably want to move on. But there's one circumstance where you don't want to do that, and it's if this is not empty, like if there's a word in here already, or a name, I guess we're calling it, but then also this is the same hash as that name, then or as what we're calling, then we're good. We're saying, oh well, that's the right thing, so we'll return that position. Okay, so search hash map is basically us saying, like, I think it's going to start at this position, I think this is the right one, but then this kind of corrects it. It says like, oh yeah, I mean, yeah, good choice, but it turns out there's already a different name here, so let's move on. This one's got a name too, but the hash matches, so that one's fine. Or if it said, oh, this one doesn't have a name in it, so that's fine. It's an and, right? So if either of these things end up being untrue, that's fine. Okay, so this is basically where we're filling the hash map, just with kind of more or less empty values. And then we'll move on to this part. This is kind of the bulk of it. I mean, basically the rest of what we're going to be looking at is just this for loop, and then we're returning the result at the end. So let's take a look. So first of all, hash is going to be assigned the value of calculate hash names at I. So this is a loop, I didn't mention this is a loop that's going through the names array. So this is the real action happening here. And we're calculating the hash. So the hash is just, we're using this to get it. It's, like I said, kind of like a way of encoding the string into a number, as far as I understand. And we're saying start position is going to be search hash map with this, so hash mod hash map size. Okay, so that's how it's determining where the first position should be. It's basically taking that unique number, the hash, and it's doing a mod with the hash map size. And so, like, if you found two things that had the same hash, then these would be the same, right? Hash mod hash map size would be the same, because hash map size, importantly, is a constant, which means its value will not be changing. Great. So then hash. Okay, so that's and just the thing we calculated here. We're using those two as the arguments for search HM, which was right up there. Okay, and then if hash map at start position at 0 is empty, so if we're talking about a situation where we've found our position in the hash map and it's an empty space, then we're just going to slot that right in. So we're going to say, well, hash map at start position is going to be assigned the value of names at I with the hash that we just found, and we're going to start with a 1, right? It was a 0 up here, it was unclaimed, but now we're starting with a 1. There's just been one of these that we found. And then result, we're going to push names at I, because we didn't have it already, like it wasn't already within our hash map, right? We didn't have, we didn't encounter something that already had that name or that hash. And so we're just going to say, oh, okay, well, we don't need to put a 1 on it because we haven't discovered one like that already. So it would just be like doc in this case, for example. All right, so then else. So this is the case where we find the start position, and the thing at that start position is not an empty string. It's an existing string. It's, maybe it's doc, maybe it's something else. Okay, so under that circumstance, we're going to say, all right, well, the new name is going to be whatever that name was, plus in parentheses, and this plus, remember, that means concatenate. So take the name like doc, and then right after that, put in an open parenthesis, and then right after that, put in, yeah, as I suspected, this number right here. So the one that we're turning into a 1 right there. And then close off that parenthesis. So basically we turn it into something like that. Okay, great. And then we're going to say new name hash, because basically now we're saying, well, we've got this thing in there now, right? Like, it's not just doc. We need to think about this as well. If we find this in there, that's a problem too. So that's why we'll make a new hash for that, because it's a new thing, right? So this is our new name. We'll make a new name hash, and then our position, very similar to what we had up here. We're going to do new name hash mod hash map size, and then new name hash as the second argument. So very, very similar to this right here. All right, so then we're getting very close to the thing we actually have to fill in here. Let's take a look at what's going on. So we've got a while loop. So after we find that new position, and we get that from search HM, then we say while hash map at position at 0 is not an empty string. So basically now what we're saying is, well, okay, let's think about this, because basically we've come up with, yeah, okay, we've come up with a new hash, and then basically what we found up here was that when we found our start position, there was a possibility that, just because of the way this function works, there's a possibility that there was actually something already there, because of this. So if there was already something, well, if there wasn't anything there, it would do this. If there was already something there, it would do this. Okay, so the thing about this one is, let's see, this is basically like almost sort of the reverse of this as far as I understand, because basically now it's saying, like, what if you had already put in doc1 to begin with, and then you'd encountered a doc and then another doc? Like, what should it do with that, right? So that's a good question. I'm actually not sure what we're supposed to do with that, but let's find out. So, all right, yeah, while the position is not something empty, while there's something already there, then what are we going to do? So hash map at start position at 2 plus plus. Oh, okay, so we're basically just going to say, like, oh, there's already doc1, we'll make this one doc2. Okay, makes sense. So we'll say new name is this, so basically hash map at start position at 2. That was yeah, this here, that number. So maybe instead of a 1, now it's popping it up to a 2. Okay, great. So I have an idea of what we're going to do with this. I think we're going to redefine position. I think we're going to say position is going to be assigned the value of search hash map. Yes. And do we have a new name hash? Oh, we need another new name hash. Let's get that. So new name hash, boom, is going to be assigned the value of calculate hash with new name, because new name changed, right? Like we've incremented the number inside, so we've got to get a new hash for that. And then we'll search the hash map with new name hash mod hash map size, and the second argument will be new name hash. New name hash, yeah. Okay, great. And then after all that happens, we say, oh, hash map at position is going to be this thing. We've found a new home for it, right? Like, since this is a while loop, it's not going to stop finding these new positions until it knows that it's found an empty one, right? And so we're saying, okay, well, this was an empty one, so we're going to replace it with new name hash, and 1. 1 because it's the first time we find one of those, right? And then result.push the new name. So the same kind of stuff that was happening up here, just a little more complicated. And then very important, we have to say hash map at start position at 2 plus plus, because remember, this was the case where there's already something there, right? So start pause, right? We found that, and either it was going to be something with an empty string in it, or something that wasn't an empty string, but it was one that we've already found before. So that's the situation where basically we would go down here instead of doing this, right? This was if it was an empty string that we found. This is if it's not an empty string that we found. So since it's not an empty string, that's why we have to increment that number at the end, this one here or this one here. Okay, so I think that should work. Let's run the sample tests, and oh, I guess I should see if those are working. Yep, that worked. Great. So we'll continue, and excellent. Let's move on to the next one. Whew. All right, so this is the code writing one. So this is really our opportunity to shine. It's not just a matter of analyzing and trying to put yourself into the mind of someone else who wrote an algorithm. Now we've got to write it ourselves, and in my opinion, it's the fun part. So, okay, I think I'm ready. Given the first two elements of an arithmetic progression, find its nth element. Great. So we're going to say let difference be assigned the value of element 2 minus element 1, actually. And then we're going to say return element 1 plus n minus 1 times difference. That's a math formula. We could have done this using a loop or something like that, but this is a known math formula for calculating arithmetic progressions, also known as arithmetic sequences. All right, so I just wanted to get that done kind of fast, but like I said, I've submitted already, so I'm pretty sure we've stopped the clock at this point. So it says, given the first two elements of an arithmetic progression, find its nth element. So basically n is the number they're providing over here. Now, okay, first of all, arithmetic progression it's a type of sequence. I'm going to call it a sequence. I mean, that's what we usually call it around these parts, I guess. So it's a sequence where we'll have a constant difference between each number. So maybe it's like 5, 7, 9, 11, 13, etc., going up by 2 each time, then starting at 5. So basically, if we want to get a number directly, there's a way we can sort of do that. So let's go over here. We might as well. Forgot to clear it again. Okay, let's clear that. And okay, so arithmetic progression, arithmetic sequence. Basically, it means we've got, let's say, we'll do a t-table. We want to look at the nth element, and we're going to start at 0. And let's say, just as like a bit of a legend off to the side here, A is going to be assigned the value of element 1. And then D is the common difference. Okay, common difference. Great. That should be more like an E. Yeah, difference. Great. Which is going to be basically element 2 minus element 1. Because if the difference between the first two numbers are the same, then the difference between all the following numbers have to be the same as well. So this will be our element in the sequence. And basically the idea is that we start with element 1. So when, okay, I'm not actually going to start with a 0 because unlike an array, we're talking about a sequence. And so we're going to start with an index of 1. So we're not going to start with the 0th element. We'll start with the first element. So we'll say that's the first term. We've got the second term, the third term, etc. So like maybe just to help with a visual here, we'll start with an example off to the side. So we'll say 12, and maybe we'll like subtract. I'm trying to think of a number that's relatively prime to 12. It has so damn many of them. Let's go with 5. no, 7, good. The decrease by 7 each time. So in other words, add -7. So this will go down to 5. 5 plus -7 is going to be -2. -2 plus -7 is going to be -9, and we'll just continue from there. So this would be a case where A was equal to 12 and D was equal to -7. Okay, so we want to try to figure out our formula over here. So the first term is A, like we spoke about. Great. The second term, well, we're going to take our element A and we're going to add D. Okay, great. The third element will have A plus D, like we had above. And then we're going to add D again, because that's what we do every step, which is going to be the same as A plus 2 times D, 2D. Okay, and then for element 4, well, we've got the previous element plus D, right? So it's going to be A plus 2D plus D. So that's going to give us A plus 3D. Okay, and maybe we're noticing a pattern here at this point, but if not, if we've got A plus 3D and we add on D to that, we'll get A plus 4D. Okay, so basically the idea here is that the number in front of the D, the coefficient for D here, is going to be 1 less than this one over here, right? So it's going to be the value of n, but then just kind of like 1 fewer. So my claim here is that if we want to know a particular element or a particular term, as we usually call it in discrete math, T sub n, so this is representing term number n. My claim, according to this formula over here, is that it's going to be A plus n minus 1 times D. And we could put that to the test. In fact, we kind of already have, because over here, that's the formula I used. So element 1, that's A plus n minus 1 times the difference, D, which was element 2 minus element 1, and it passed all the tests. Okay, cool. So I guess that's it for the fight. Let's see what the outcome was. So go to next. We're still waiting for the opponent. So what does that mean then? Because if you initiate a battle, I thought you had to go like right into it, right that moment. Okay, so we'll see about that, I guess. But anyway, if you look at the scorecard here, I mean, the first one not too bad. The last one not too bad. The middle one kind of tricky. So we had a bit of trouble with that one. But anyway, not too bad overall. I think that's good. So I don't know why that's still doing its thing. It's a little troubling. Anyway, that was the battle. Hope you enjoyed it. Let me know if you have any questions, comments, or concerns. And if you want to do a battle, then get at me. Zero Cool. This is your guy right here. So we can. You can do all the battles you want. Anyway, bye.